Good evening, everyone. My name is Paul. I'm a Scala developer at The Guardian, and I am going to talk tonight about parsers. And in particular, I'm going to talk about FastParse, which is a Scala library for writing parsers. So when we think of parsers, often we associate them with the processing of really complicated grammars, like in programming languages and stuff, and that is probably where they're traditionally most at home. Maybe that's because traditionally they've been quite difficult to write, require a lot of technological investment in order to create them. But I think if we actually think of parsers in a more generic sense of just being a set of rules which are applied in the correct order to take unstructured data and convert it into structured data, then that definition allows for quite a large variant in the scale and complexity of those parsers. And so, converting unstructured data into structured data is something that as developers we do every day. So maybe if they were a lot easier to write, then we might find that we would use them a lot more frequently. So what I'm going to look at this evening is the idea of whether parsers are applicable to more use cases than we might traditionally assume, and then also to have a look at some of the possibilities for writing them in a lot more easily with Scala, particularly with FastParse. So if you were to try and process some unstructured data, if you're like me, probably the first thing you would do is reach for regular expressions, which of course they're brilliant in the sense that they are generic and flexible. You can use them to do pretty much any kind of search. And the key advantage for them is that you can provide, by just having a string input, you can provide for users of your application the ability to do all kinds of complicated searches without you having to know anything in advance about their data or what kinds of things they might want to search for. And of course, they will already know regular expressions, so they'll be able to reuse that knowledge. However, all of that flexibility does come at a price, because they're not extremely efficient in terms of if you were to compare it to something that was written specifically to parse a format that was known in advance. So they're great for sort of one-shot things like doing stuff in your editor, but they can really suffer in efficiency and performance compared to sort of large-scale processing. And also they are not recursive, so if you want to create something a bit more sophisticated than just matching the sort of a string with do some fuzzy matching on a string, then you'll quickly find that it's quite difficult to create sort of a nested structures. And so if you are doing something which requires more detailed parsing and you're a Scala developer, then you'll probably take a look at what's available, and you'll probably tread a path similar to the one that Lee Howie did when he developed FastParse, or when he decided to develop FastParse. So if you have a look at what's available for creating parsers in Scala, you'll almost certainly come across, really quickly, you'll come across the Scala parser combinators library. It's a really sort of well-known and revered library. It used to be part of the Scala standard library, and it's also discussed in detail in the Programming Scala book. And so it has quite a good reputation. It's a really functional, really model API. It's really nice to use, it's really beautifully written, and it definitely is something to use to learn the best way to write or the best kind of functional API. However, if you start to use it for anything really complicated in production, you'll quickly find, as the author of FastParse did, that it is quite slow. So this is a benchmark. I recreated a benchmark that he did, basically running some JSON parsers created in various libraries, one of which is parser combinators, and we can see that this is parsing the data in significant, so this is how long it takes to do 100 iterations, and we can see that it is orders of magnitude slower than the alternatives. A particular note is play JSON, which is So that's like a hand-rolled parser that's specifically designed by a human to parse JSON. So that's always going to be faster because that's specifically written for that use case. But the two options that we've got here in the middle, FastParse and Parboil 2, they're both libraries, they're both parsers written using libraries designed to make it easy to write parsers. So it's really amazing that actually they're able to get comparable results in speed there. So you might ask, well, why not just use parboiled? Well, the answer really is that although parboiled is really performant, it's actually quite fiddly to use. So definitely, Harry was looking into it, into the state of parsers in Scala. He saw that Parboil 2 was producing all kinds of unwieldy error messages, particularly like if you make a small mistake in your parser, then you'll end up with loads of shapeless type errors and stuff, and it's very difficult to use. And so although it is an excellent library and it's really performant, there was the author of FastParse thought, well, maybe there's a possibility to actually combine. It must be possible to combine the excellent API of parser combinators along with the performance of Parboil 2, and that is what he set out to do. So some of you may already know Lee Howe. He's a really talented and prolific developer in the Scala community. He's written loads and loads of really cool libraries, some of which I've listed up there. And I really like his brand, if you want to call it that. Like, what I always associate it with is really sort of lean and practical libraries. So I always know that if Lee Howe has written a library that will do the task, then I'll be able to get started in just a few lines of code. And it won't necessarily have a load of boilerplate or extra things that I don't need. You definitely, like for example, micro.json is a really nice little library that you can use to parse JSON create JSON parsers in a really small amount of code. And so, why he decided to create FastParse? Why is it fast? Well, in his own words, it's because although FastParse has a really nice functional API, internally it is implemented in what he describes as really gross and ugly way, because he's been quite happy to sacrifice the internal functional API to create a really performant library. So, for example, it instead of allocating new objects constantly as it's running, as it's processing various different parsers, like you would do with the parser combinators, he actually creates mutable data structures that get created in the beginning and passed down. So I did say the M word there, not monad, but mutable. But hopefully, because of the performance of the library, we can sort of forgive that, because all of that is hidden inside, and externally it is a really nice functional API. He also implemented quite a bit of ahead of time optimizations, like creating lookup tables from your parser and things like that. And in addition to that, he addressed the problem of not having great error messages by adding loads and loads of logging in there. Now, the logging is entirely optional, so when you're developing your library, you will pin these sort of log messages onto the end of your parsers, and you'll end up with much nicer error messages, which tell you which parsers it actually tried to attempt and which one failed, and exactly what would have made the parser succeed at that point. So that's really useful, and of course that comes at performance cost, but you just turn that off when you're in production and it doesn't affect it. So he achieves this by basically, if you have logging enabled and your parser fails, then it will actually run the parser again with logging enabled. So big performance hit, but massive help in debugging. So I'm just going to try a little bit of, if I feel courageous, I'm going to try a little bit of a live demo. So so you probably notice I'm using Ammonite here, because I'm a bit of a Lee Howe fan, as you probably can tell. But so let's get started. So it's a bit difficult to do this while holding the microphone. So the first thing that I'm going to do is, as you would expect, I'm going to import the FastParse library, we'll see sort of a little bit later on why I've had to import two things there, but basically I'm making a choice about what kind of semantics I want to use for the repetition operators and so on. So the next thing we're going to do is get some input. So what we're looking at here is this is just some mocked up logging files. So this is just some input, and if we look at it, we can see that it has So it's, as you'd expect, got some date stamps and a message. So this is just the sort of thing that you might have to parse. And you might often use a regular expression for this, which is great if you don't know in advance what you're going to deal with. So if you're writing grep or something, but if you're writing an application which passes the same log file format over and over again, it might be much more efficient to apply in advance the kind of optimizations that a human would be able to do. So now we get to the actual meat of it, where we're creating a parser. So if you're like me, this syntax is actually quite scary. That's what I thought when I first looked at it anyway. It seems really out there, especially when you compare it to, say, parser combinators or something. But it's actually just sort of the Scala that we all know and love. So it's, if we actually look at, so when how he's actually suggesting here is that you can use this sort of shortcut, this _p shortcut there. And what that will do is people who've used type classes will immediately recognize that as saying that I need to have an implicit instance of a type that matches, that is parameterized on this p. No, type of p that's parameterized on my input type. But my input type is underscore because I don't care what type it is. So what that means is I'm basically running the parser is going to be a function which takes an implicit argument of type p. Now, what's p? P is just the mutable context which I dared to talk about earlier. And so P is just a nice little shortcut type alias to make that more convenient to type. So if we go back to the demo. So there we go. I have now typed in, so I've defined my demo, defined my parser, and we'll see that it is actually a function. And if we want to parse it, because it is a function, we have to use this sort of weird syntax where we're saying, so it looks like it doesn't take any arguments, but of course it does because it takes an implicit parameter, so we have to say that it is a partially applied function by using the underscore. So that is really annoying actually, and it's a bit inconvenient to use, I'm not going to lie to you, but it works. And it's how we achieve the speed. So once we've defined our parser, then we'll notice that although the parser succeeded in passing a bit of this input, it didn't return any results, which is probably not what we expected. So the reason for that is because this is one thing that's quite nice, I think, is that the FastParse by default doesn't capture anything, because actually in the most common case you probably don't want to capture. So in order to actually capture some data, we have to put this exclamation mark on the end of it. So a little bit fiddly, but once you get used to it, that makes sense. So we just take our parser, and so what we're doing here is when this parser is called, it will also call the other parsers, and it will pass in implicitly the current context that we received through our bounded context at the top. So now if we run the parser again, we should hopefully find that we now have a result, which is 2. That's great. So now we can get a bit more advanced, and we can say, well, actually, there's quite a few fields there inside that that date, and they're all numbers, but they're separated by hyphens. So what I should probably do is make that a bit more generic. So now I have a parser which will pass a number, and I'm using the repetition operator there, so we can. It's not an operator, sorry, but I'm using the repetition function there to say that I want to match this at least once, but any number of times. And that's where the importing of the white space comes in. If you import a different thing instead of that, no white space, then you will actually have to explicitly handle or not handle, as your case may be, the white space. However, because I've imported the no white space, I'm getting the repetition operator that ignores white space. So that's a neat little thing, because you can inside functions, you can change the way that the operators deal with white space, which is quite neat. So as you would expect, you can apply operators to the parsers in order to combine them. So that's what I'm doing here with date. So I'm saying now that the date is 3 numbers separated by the hyphen, and we can see that there is no exclamation mark attached to the hyphen, they're not capturing anything. So what I should end up with if I put this through the input is that I should be able to capture just the numbers, just the numbers, and I haven't caught the hyphens. But of course, this is a string. It was already a string. That's probably not what we want. We don't want to make dates out of strings. So what we're going to have to do then is map it. So all of this will be familiar to people that are comfortable with the other M word, monad, because I'm using map to actually, in this case, apply a function to the number to convert it into an integer. And then that will give us a parser that returns a type of integer rather than a type of string. And we can then go on and combine those to actually map that into a complete, so again, I'm just sort of reiterating that we can map them all together and create, so the idea is you're creating a larger parser by combining smaller parsers. You can test the smaller parsers, make sure they're all working, and then you can build larger parsers out of it. And at the whole time you can, when you need to, you can apply the logging to get some nicer information. So when you're debugging it, you can start at the top level when you know a parser isn't working. You can make it into a logging parser and then try it out. It will tell you which ones it succeeded, where it succeeded and where it failed, and then you can drill down bit by bit, same way you would normally do like with print lines and stuff, except with this you can actually inject some effectively print lines into the execution of your recursive parser, recursive descent parser. And so, as you would expect, you can develop that further into something which is able to actually take a log entry, take a more sophisticated class like case class and convert that. So, this is not going to be faster than code you'd written by hand to specifically process all of this data, but it probably is going to be faster than a regular expression you'd written. Because you're able to apply domain knowledge to, especially if you start doing things like implementing cuts, which is part of the library as well, where you can say there's no need to backtrack here because I already know that if we've got this far, then we can't go and then the next one won't match and things like that. So essentially, the point there is that this is somewhere in the middle between complete control and not much control at all. So. In conclusion, I would just like to say that I think that, so when you use a library like FastParse, writing parsers is really easy, or at least compared to trying to use like Antler or something like that to create an entire parser from scratch. And that means that they can potentially be applicable in other use cases where normally we might immediately use more generic and less efficient tools like regular expressions. And if you are interested in using parsers in your Scala project, I would highly recommend at least taking a look at FastParse because it's a really nice library to use and it performs really well. So keep that in mind, and hopefully that will possibly add something else to our armory as developers. There's some links there, but is there any questions? If I have time, I'm not entirely sure if what time I'm supposed to finish, but if anybody has any questions.